Hey everyone, this is Unit 8.5 Solving Exponential Functions. Every exponential function that you will see will most likely be solved using one of two methods. 1. Changing the coefficients so that they are similar bases, and 2. Using the power law of logarithms. The first method is easy. It's just changing the bases of powers, which we have done in earlier grades. The first part of this should be a recap. It says that we should express the following equations by using the base of 3. The answers for them are 3 squared, 3 to the power of 6, 3 squared, and 3 to the power of 6. Always remember to make sure that you change your coefficients first, then apply any rule that you have learned. For example, number 4, we did the numbers in the brackets, then applied the power of power rule on the powers. I hope that was a good enough review, so now we are going to try and do this method, but with exponential functions that are a bit harder, with the variable that is an exponent. Like always, we deal with the coefficients first. In example 1, I replace 32 into 2 to the power of 5, which completes the first part. Now that the bases are the same, we can try to solve for the variable to make the equation true by removing the bases since they are already proven true. So the answer is x equals to negative 7 over 4. Number 2 is basically the same format. Change the 9 into 3 squared and apply the power of power rule, which gives us this, and now solve for the variable, and the answer you should get is x equals to 0. The last part is a bit trickier as you have to change both bases of each power, which gives us the answer right here, then solve for the variable giving us x equals to 6 over 13. The second method is to use the power law of logarithms. To solve equations like these, we first take the log of both sides. Next, using the power law of logarithms, we can take the exponent and rewrite it as the coefficient of the equation. We do this to make it easier to isolate the variable from the exponent. Next, simplify the equation by distributing the coefficient. Now, we must collect like terms by placing the polynomials with a variable on one side and the ones that don't on the other. Next, factor the equation. For example, the variable side has both an x, so we can factor the left side of the equation. Next, use the product and quotient rules to simplify the equation further. 2 logs being subtracted results in a single log with the numbers being divided. The same goes with 2 logs being added results in the numbers being multiplied. And finally, solve for x, which in this case you should get x is equals to 5.3013. When finding the answer in your calculator, you might have to input it a little differently depending on your calculator. Do the same steps with the second example. First, take the log of both sides, then rewrite the exponent as the new coefficient. Use distributive property and collect like terms. Factor the x, and for this one you have to distribute 3 into 6 with 3 as a power, so it's 6 to the power of 3. Do the same thing on the other side with 2 being the power, which is 5 to the power of 2. Use product and quotient rule and solve for x, which is 1.3306. Now that you know how to solve exponential functions, try this on your own.